so much, Pete. It's a real pleasure to be back at DataEngConf for the second year in a row. And I'm joined by some really illustrious panelists, and I'm going to begin the panel by asking each of you to introduce yourselves and talk a little bit about what you do. Emoji, do you want to start us off?
Yes. So can you guys hear me? All right. So my name is Amoju. I do data science at GitHub. Before I went to GitHub, I was finishing my PhD at Berkeley while concurrently working at Google, Google.org specifically, co-leading nonprofit investment in computer science education. I'm extremely nosy as a human being, so data science is perfect for me. I just like to know stuff. So I can't believe that we actually get paid to do this.
Jennifer.
Hi, so I assume you guys can hear me too. So I'm Jennifer. I'm the head of data science at Atlassian. In case you don't know what Atlassian is, I'm pretty sure you use at least one of our products. So we're the company that makes Confluence, Jira, HipChat, Trello, and a ton of other things that pretty much everybody's using. For some reason, people know the products, not necessarily the company, so that's why I'm mentioning that. So I joined a little bit less than a year ago to start a brand new data science team over there because Atlassian was a server company for a long time, so there was a ton of data being generated, but unfortunately we didn't get to look at it, and so eventually the company started migrating to the cloud, lots of opportunities, and like many other companies, they started realizing that there is a huge opportunity. So prior to Atlassian, I was I was managing data science in the search team at Walmart Labs, and I'm originally a particle physicist.
And Shubha.
So I'm Shubha, and I lead some of the data science efforts at Salesforce Einstein. We're building a platform to enable all the hundreds of thousands of businesses that use Salesforce to much more easily use machine learning in their day-to-day businesses. And so prior to Salesforce, I worked at LinkedIn. I used to work on search, and before that, I worked at Microsoft Bing. On making, incorporating social signals into search results.
All right, so we're the past, present, and future panel. So I guess we'll go in chronological order and start with the past. I'm curious I'm curious for each of you to tell us about what is a hard problem that you are proud to have solved in the past, but now it's done. Now it's sorted. How about
All right.
Go Emoji, then Shubha, then Jennifer. I'll keep mixing it up.
Okay. So the machine learning team at GitHub is fairly new. We started in January 2017. And because of that means that we're building the team as well as building the infrastructure to support machine learning at the same time. And we built a recommendation engine. I don't know, a lot of people, if you log into GitHub,
how many
and you
of you
look
are
at
GitHub
how
users?
many, I think everybody pretty much uses GitHub.
Let's just
but
say
if
show
you're
of hands.
logging,
Show of hands. GitHub users. Everybody.
yeah. So if you log in and you go to the dashboard, the second tab is actually a recommendation engine. I know most of us just go straight to the URL of our repos. That recommendation engine is something that we're very, very proud of that we built because we're able to build it at the same time as we're building our team as well as building infrastructure. So it makes us not have to leave outside of machine learning and go into data engineering as well. So working together, going all the way from ETL to production in a very short amount of time, it's something that we're extremely proud of. And I want you guys to actually use that product and also leverage the social graph on GitHub. Follow people, like stuff, so your recommendations can be better. And we're very, very proud of the quality of recommendations because sometimes we actually use the recommended repos to build the product to recommend even more.
Shubha.
Okay, so prior to Salesforce, I used to work in the consumer space. So I used to work on at LinkedIn and at Bing, and the problems that we worked on that I worked on were pretty constrained in a sense. So I had to solve for one very well understood problem with a very well understood objective, using data that I understood really well and that I had good intuition for it because I use these products myself. And I found that transitioning to the enterprise space was just a completely different beast. We're trying to make machine learning accessible to the hundreds of thousands of businesses that use Salesforce applications. And they've all customized these applications for their own needs, and they use it for all kinds of things. So the diversity of data and the diversity of use cases and the diversity of business processes is just mind-boggling. And so my team, from like the very first product we started working on, we've had to build a lot of automation. So how do you automatically do the things that a data scientist would do on every single data set that they work on? Because we just don't have enough data scientists to do, to solve all these problems for all these businesses. And so that has been extremely technically challenging, especially like when you don't, when you're working with unknown business processes, things like even just separating out cause from effect can be very difficult to do. And so, so it's been technically very challenging, but at the same time really rewarding, because ultimately we're making machine learning accessible to people who don't necessarily have a PhD in machine learning, but they have a lot of domain expertise that they can bring to the table. So that's something that I'm pretty proud of working on.
That's great. Jennifer.
Yeah, so like as I mentioned before, I come from an unconventional background. So I'm originally a particle physicist. So basically, my story is that the first time I actually took a data science job, I actually became a manager by accident, because by the time I joined the company, after signing, my manager eventually left, and the entire venture was essentially starting a brand new data science function. So I ended up like by accident having to build a data science team from scratch. And so I don't know how I pulled this off, but like somehow I was able to hire like 7 people really quickly, and I actually realized like this is something that I'm actually pretty good at, and it's actually very challenging. And so I'm just like I actually like over and over, like I actually really enjoy building teams from scratch, because there is the technical aspect of the challenge, but there's also like a cultural aspect to the challenge. And so if I have to think about like bringing data to a team and like making companies data centric, making teams data driven, I think like there is one thing I'm really, really proud of, and it's actually what happened in my previous job at Walmart Labs. So basically, I actually joined the search team, and so the reason why I joined the search team compared to like an Amazon or something else, I actually wanted to be in e-commerce, was Walmart has a very different challenge. So actually, like when you work there, Walmart is a company that's mostly brick and mortar, right? And so one of the problems that the search team for e-commerce has there is that people would actually use search to try and check the inventory in their nearby stores, right? So when you think of using machine learning for search, it's actually a huge problem, because you don't have a clean feedback loop, right? And so people would actually search for Band-Aids, and they would actually have absolutely a zero intent to order online. They actually just want to see if this is available in their nearby store, because they don't want to drive there to find out that the item is not available, right? And so I actually realized it's a huge problem, and so I actually set up my mind to go and try and fix this problem. And I realized that the data scientist on my team actually didn't have access to stores data, because the data scientist on the e-commerce side had access to e-commerce data, and the data scientist on the store side had access to source data. And I really pushed really hard on my manager's manager, went all the way up to the CTO and the CEO, that we actually need to leverage our data better, because we're not gonna be able to solve this type of problems, right? And so eventually they gave me the budget to build a team that was just focused on leveraging data across the board, and we were able to like accomplish really amazing things that nobody was able to tackle before, right? And so it makes you realize that even a company like Walmart, and Walmart was one of the first companies to actually like leverage data, like they were already gathering data in the 90s, where nobody else was actually realizing what data could bring to a company. Still, they were missing out on something really, really important, that even in the case of like their e-commerce business, they could leverage stores data, because there was so much more data to look at. And I think this is something that I'm really, really proud of.
I mean, you said something interesting there, which is you talked about creating a data culture. What does that mean to you? How do you create a data culture, especially if you're, as many of you have done, if you're coming into a company that was not previously a data company and is kind of trying to acquire a data culture? What does that mean?
Well, for me, like it's mostly a cultural change, right? So basically, like something that I see in my current job is like so when I came into Atlassian, you have people working on data for like understanding customer churn or whatever, but nobody was leveraging data to actually build a data product, right? And so I came into this environment where people are very engineering oriented. Like think about it, right? Atlassian is the company that makes software for software engineers to perform their jobs better, right? And you actually start realizing that, we should be using Agile because Atlassian is all about Agile, but Agile for data science, what does it mean, right? How can we leverage Agile? Return on investment on a data science team is completely different than return on investment that you would see for engineering, right? So how do I communicate that to the stakeholders? How do I communicate with my product manager? How do I communicate with my engineering team? So it's a lot of patience, a lot of teaching, a lot of educational, like talking or whatever. You have to address different audiences differently because they see the problem from a different angle. And for me, like it's mostly about like educating people.
Mojo, you were a founding member of the data team at GitHub.
Yeah.
What were your experiences there? Like,
So,
what had to change about the culture?
So a founding member of the machine learning team. They already had analytics. But the interesting thing about GitHub is a few years back, it was an organization with no management. So it was all completely flat. And a lot of products were driven by engineers because they're building products for themselves. And the biggest challenge that I have seen and that we're actually going through is to empower the engineers to actually understand. They don't need to understand high-dimensional spaces and vector representations. They don't need to know any of that stuff, but they just need to know a few primitives. So as you're designing products and ideating around product, I want you to be able to think about, could prediction help me here? Could relevance help me here? Could ranking help me here? So giving them like those few primitives like predict, rank, recommend, just things that you can easily think about and see if I could recommend something in this workflow. Will this help this product become better? So they then see, this is where machine learning and a data product can actually come through. So it's been about education, but an education that they don't need to go deep into, but just something they can count off in their hand, wrap their brains around, and actually reason about it. So the biggest challenge for us is helping people, supporting people in reasoning about product from the data product perspective. So it's all about education.
How about you, Shiva?
It's a similar thing here. So there's been a lot of education, especially with product managers, around, well, why do you think that this is something that would be good to build? Like, what data do you have to back it up? Have you instrumented your product correctly so that you can actually measure the impact of what you're building? And how can you quickly get out something without boiling the ocean and iteratively release stuff and get signal and improve? And I think just getting product on the same page has been a big piece of improving the culture around data.
On to the present day, if I think about data science and machine learning, in the news, in the sort of national consciousness, I feel like what's actually sort of top of the headlines right now is, Mark Zuckerberg getting grilled by Congress and just kind of all these looming concerns about data privacy, about the potential for automation and job loss, about the possibilities that AIs can encode bias and discrimination, and maybe people have always had fears about new technologies. This feels like much more significant to me than fears people had about the cloud or mobile. What are our responsibilities do you take these concerns seriously? What are our responsibilities as practitioners, either to sort of explode the myths or to take substantive problems, and solve them? Maybe we'll start with Shubha and come this way.
So I think one of the areas I think a lot about is bias, and I think it stems from. So the thing is that I guess machine learning models are only as good as the data that you feed them, right? And a lot of this data comes with deeply ingrained human biases and human prejudices. And so as we're automating more and more things, through machine learning more and more decisions, there's this danger that we're taking these biases from data to decisions. And so we have a really big responsibility here to be able to measure and to be able to fix for these things, because we want to ultimately design for the society that we want to live in. And so I think we need to tackle this at many levels. First of all, the teams that build these AI applications need to reflect the diversity of the populations that they're building these applications for. So a classic example, I think, was there was this time when seatbelt car manufacturers were making seatbelts, and they were only training on male models. And so the result was that women and children were still dying. And so I think having a lack of diversity in your design team and in your teams in general results in poor design choices. So I think we have to start with the teams that are building these products. We also need to bring much more transparency and insights into the models themselves and why they're, provide insights into the factors that are influencing the predictions.
Or about explainability.
Explainability. And even at the level of like a particular decision that was made, why was this decision made? What was the main influencing factor? Being able to provide that kind of transparency it's an important area of research, and it's important that we put more and more effort into this. And then I also think that just generally having metrics around everything, like if there are certain things that you care about, like race or gender, then having metrics and knowing how you're doing against those particular categories is important, because you can't start to fix what you can't measure. And so I think there's a number of levels at which we need to think about this. And ultimately, though, I'm kind of hopeful, because I think you could train a machine to overcome its biases by giving it better data, but how do you train a human to overcome his prejudices, right? So I think.
How about you, Jennifer?
Yeah, so I think my, specific worries in the context of my job might be slightly different, but it's probably a problem you have yourselves at Salesforce, right? I mean, so think of the data that Atlassian has, right? I mean, so basically, like a little bit over 100,000 different customers meaning companies using our services, right? I mean, so basically, user-generated content for Atlassian is pretty much everything that you cannot find on Google, right? I mean, so basically, what Tesla is working on, basically, all the secrets of what happens at an enterprise level are stuck somewhere in our data, right? I mean, so obviously, we're being very careful with this data, and we want to make sure that we're not leaking very critical information from one company to another, right? I mean, so typically, the type of products we're trying to build are recommendation systems and these type of things, right? I mean, so when you're building a collaborative filtering model for recommendations, obviously you're just gonna use the data of each one of these companies separately, right? I mean, so you need to duplicate the same model over and over again, because I'm not gonna recommend something from content from Tesla to someone from Netflix, right? Obviously. But then you have more advanced kind of things, trying to profile a specific user, right? Because, for example, if I can say that a specific user is a product manager, maybe I can start ranking things differently in search so that they can find content that's more appropriate, right? So we're thinking about building these models that help us profile users. And question is, do you want to do that on a customer by customer basis? Obviously, you wouldn't have enough data to do that properly, and you're trying to do that more at an industry level or even across all of our customers. Question then, right? I mean, so what does it mean to leak information across different companies, right? I mean, so knowing when you are going to leak actual content is fairly easy, right? But when you are going to leak patterns, hidden information, right? I mean, coded information from one company to another. Is it okay? Is it something that's going to be, possible to reverse engineer for someone else, right? I mean, there is a very common problem for search specifically, called basically you can backtrack and try to figure out what exists in other instances by just looking at the ranking scores from another company, right? And the question is, there are new regulations like GDPR, right? I mean, GDPR is coming soon, but even for me, I know how to.
Quick audience poll. How many of you are familiar with GDPR? How many of you are like, GDPR is not a concern, it's no sweat? Okay.
Yeah, so it's a good topic, right? So,
Maybe we should have it. All right, the next question is all set.
So actually, I spend a lot of time saying, like, I get it what it means to be forgotten, right? I mean, just erase the specific user's data from the system. But what I've learned about this user, what do I need to do with that? And I spend so much time like talking to the lawyers, like, is it okay to keep that? If you can, if you cannot directly identify this person, it's okay, you can keep it. What does it mean? Like, if you have a reasonable doubt about who this person is, right? I mean, in your data, I'm just like, what is reasonable, right? I don't know, you figure it out, right? I mean, so it really makes you realize that something so critical, so crucial or whatever, and you're seeing how important that is with like the Zuckerberg hearing, right? I mean, basically like we still have a lot of work to get done in terms of like identifying what is okay and what is not okay. And for me as a data science manager, it's really worrisome that I have to make some of these decisions myself. So sometimes we just pause and we just decide not to do things because we're scared of what the implications might be.
I mean, those hearings are definitely not reassuring that the lawmakers are in a position to make these decisions.
Definitely.
How about you, Emoju?
So when I think about some of the things that keep me up at night is the idea of the impending, maybe it's not impending, maybe we're already here, the fourth industrial revolution. So moving towards automation. And what does that do to society? Does that disrupt society in a positive way? Does that disrupt society in a negative way? And whatever it is, what's the outcome, and what can we do if we feel like there's going to be a negative effect on society at large? What can we do to mitigate that effect? Which is one of the major reasons that led me to a place like GitHub, because GitHub has all this massive amount of computational data. So we have a role to play in how we are going to fix some of these challenges. And if we're moving towards knowledge work, that means that we might be able to create something in the time to create the future of augmented knowledge workers. And with all our data, we can then use our data to help kind of lower the barrier to entry by building artificial intelligence that support people in how they learn. Very futuristic, very interesting. However, if I have to support you in how you're going to learn, and these are the kind of things I want to do, that means that I need to know a little bit about you, which gets to information that is literally about you, so I can really help you get things done for yourself. And we don't have that kind of information. It's not the kind of information that we keep on any of our users, because that's not been something we've been interested in, and we just want to support people. So it opens this whole new Pandora's box. Around this time, everybody's already freaking out about data and data privacy. So building certain kind of products requires you to have a certain kind of information about a user. And so it comes back again to the idea of education. How do we help the public understand what happens in data companies and the kinds of information that data companies collect about them? Are users going to be okay with us collecting data about you if that data is used to serve you better? Where does that line draw? And so it's also conversations with legal. What can we do? What can we not do? So that's one part. Another part is making sure that you're building data products that are free and fair of bias against humans, things that are not going to hurt the humans negatively. And in a global company, that's a very interesting problem. You want to make sure that the data products you build do not affect people who are marginalized in their society. So in the American context, we have protected persons. Does that hold for Australia? Does that hold for China? Does that hold for Nigeria? If African American Black people are protected persons in the United States, and I have something that is going to deal with that, that model is not going to work in Nigeria. Because everybody is African, everybody is Black. So these are now questions these are the things you're just like, oh my God, it's not trivial. It's not trivial at all. And I go back to building interdisciplinary expertise. We are at the point now that applied mathematics is not enough. These are not just pure math problems anymore. These are problems that require you to meet with a lawyer, maybe meet with a social psychologist, maybe meet with this. So we actually need to start looking to hire people with interdisciplinary expertise. If we cannot do that, if those people don't exist, we need to partner with people in other social sciences to actually help us in answering these kinds of questions better so we can build that knowledge into our products. I think that's where we are, and that's the kind of approach we should actually take.
I've often, what's interesting to me is I think we've actually never been at a better moment for collaboration with social science. I mean, I think arguably technology, I love what you just said, I think arguably technology always needed to be deeply concerned with social science, but in some ways, because of the emphasis on stats, like I think these days a sociology major graduates with more statistics than many CS majors do.
Yeah.
And so data may finally give us the bridge that, the common ground between the social and the computer sciences, or that'll be my glass half full take. I'm curious, in this audience, how many of you are concerned that AI is going to replace jobs, that it's going to destroy jobs currently occupied by human beings? How many of you are worried that AI is going to replace your job? All right, I don't know if I have the answer, but I think that gives us a responsibility, right? Everybody in this room, and hopefully it gives us some empathy too. Let's talk about the future then. This is probably a good segue from the present to the future. Whoa, voice of God there. So when you think about, I'm just an optimist. I'm a believer, actually. I mean, I think we need to be aware of potential problems so that we are empowered to solve those problems. I believe we will find solutions to problems that we know about and care about. But I'm gonna, when I think about the future, we've already talked about the scary things, but let's talk about the great things. What's coming that you're excited for? Like what's just around the corner and we can't wait? Not like the far future, like someday rocket ships. I don't know. Rocket ships to Mars. That's not the far future anymore. But what's just coming? What's in line of sight, but we just aren't there yet.
Okay, so I sit next to a team that. First of all, how many of you are computer science undergraduates? How many of you actually did computer science at your job? I think that's not the case. I think most of us are doing software engineering. You're not at your work doing big O notation and things like that, and figuring out NP. You're not doing any of this kind of stuff because who does that? However, people don't really do that, turns out. Software engineers don't anyway. Computer scientists still do. However, in a place like GitHub, where we have this giant trove of code, we're finally at a place where it's just like, yes, I can finally do computer science. Because the thing that is around the corner, hopefully within 2 to 5 years, is moving towards a system that has a version of automated coding. So not automating the machine learning pipeline, but literally automating things that we have some design patterns that are so obvious that we keep writing over and over and over again. Things like a for loop. If you've written one for loop, must you write it again? Like it's just the same exact primitive, the for loop. What if we could actually just do that for you? So around the corner, we're going to get to a future where you, as a software engineer, somebody who's writing code, spends most of your time on the creative aspects of code. You're not there trying to build some development environment. You're not there writing things that don't really help you get far. So the human does what the human can do very, very well, which is raw creativity. The machine does all the boring stuff that the machine can do very, very well. So that is something that is very exciting for me. I'm trying to build a product for somebody that has a great idea and feels like, oh, I can't get this idea to market because I don't know how to code, I don't know how to do this, I don't know how to do that. I want that person to come on the GitHub platform, and maybe if they put 3 months of effort, they can build a prototype of something and deploy it without having to fight through everything. That we're going to get to in the next 5 years.
That's great. Jennifer.
I'm excited about AI augmented intelligence. Okay, so basically, like I know everyone in this room is excited about like the prospect of everything being automated and like fancy AI applications. But I think we kind of missed a step, right? I mean, so for example, I worked on search, right? I mean, try to evaluate search relevance without using human input, right? I mean, this is something that is just mind-boggling that just like even Google is still using like a ton of like crowd crowdsourcing to identify what is relevance, right? And so I think there is a huge pool of new applications we are not even foreseeing yet that human in the loop, right? I mean, what happens when you are actually putting humans together with machines rather than just jumping to the machine doing everything on its own, right? So think about chess, right? I mean, so who is able to win chess competitions today, right? I mean, so obviously we know that the human has been beat by the machine, but now the best teams in the world are combinations of computers with humans, right? Because we humans are really good at strategizing, thinking about the future, right? Where we really suck at is we're humans, so we make silly little mistakes, right? I mean, so basically, this is where the machine can help us, automating, making sure that we are not making a coding mistake somewhere, right? I mean, or really making sure that we can see the high dimensionality cases and be able to evaluate all the different possibilities. And when you bring these two together, I think there's going to be a huge potential of new applications we're not even thinking about today, and that may be completely fully fledged 5-10 years from now.
Shubha, bring us home.
Okay, so I think what excites me most is I think that there's some industries that stand to be completely disrupted by AI, by data science, and a big example of that is healthcare. I think so. The fact that you can now have image recognition capabilities on a mobile phone. Just imagine the possibilities for medical diagnostics in rural areas, in developing countries that don't have access to proper medical facilities, right? So I think there are those kinds of things in healthcare and customer service and other such areas that are going to be completely disrupted. I also think that AI will fundamentally change the way we connect with each other and with the world. And a great example of this is I was reading recently about Google Pixel Buds. The fact that you have real-time translation, it's like the Babelfish is here, right? Mm-hmm. So that to me that's amazing. I was also reading about this a Stanford experiment where they were able to use Google Glasses to help autistic children infer, certain cues, social cues from facial expressions. So I really think that AI is going to change how we interact with each other, how we interact with the world. And then I'm also excited that it's going to, as both of you mentioned, it's going to take care of the mundane, the repetitive, the dangerous, and it's really going to free up humans to do what humans do best.
Fantastic. All right, I think we've got time for a couple of audience questions. The audience is still asleep. I think somebody's running a mic. Is that over here?
Right there. Oh.
Right here. Label data like a boss.
Thank you for the panel and starting off the conference. I liked, Jennifer, what you said, that you believe in a hybrid future of human and machine. And I think you were also referring to Garry Kasparov, who said that machines will beat the best human, but human plus machine will beat the best machine. How do you think that we can bring these both worlds together in a very efficient and effective way? So how would you think that in 10 years from now, humans and machines collaborate?
No, I strongly believe you're like that. I think right now most of we use crowdsourcing in many different industries to actually focus on. I mean, you label data, and this is where the human plays a role, right? I mean, so you label relevance scores for specific queries, etc. I think that somehow active learning, so the ability of continuously being, I don't know if you're you know the details of active learning, but active learning is basically one of the biggest problems we have now is deep learning is data greedy, so you have to tag a ton of data, and it's really expensive, and it's not really efficient, right? I mean, so active learning is really about you just ask what you call an oracle, so it can be a human or another system, so to basically give you a label when you need to, right? I mean, so basically basically you would build a system, you would predict something, you would get some data out of this, and it would tell you like a level of confidence on your answer. And if your level of confidence sucks, you're just gonna ask, hey, human, please tell me if this is actually true, or please like provide more and more data. And so I think it's really a smart way to incorporate like continuous feedback from the human in the loop. That's actually gonna help us like do much more, because right now we're really stuck by this problem that we cannot label every single data point because we're in an era of big data and we cannot label everything manually, right?
Over here.
Hi, thank you all for your participation on this panel. Everything has been great. I especially loved what you had to say about, for me, the first time I heard this particular twist on like data-driven, because like whenever management would come to me and say we have to be data-driven, it's like how do we make better decisions? But this whole question of in product design, how do we embed data science to empower users to make better decisions, which I think is awesome. The question I wanted to ask was kind of a flip extension of that. We've been talking about data science. The other half of this conference is data engineering. What do you need from us to enable you to do these things?
Infrastructure that is extremely robust at scale. And I don't have to like tie this, tie that, ETL should not be a nightmare. I shouldn't have to like cook all these things together. So I need infrastructure that is extremely robust at scale and ways of detecting errors in the infrastructure very, very fast, so that I'm not doing like a whack-the-mole, like, okay, let me go through the server logs. Was it this? No, it wasn't that. Was it that? No. So just better diagnostics.
Yeah, I think metrics in the pipelines are generally overlooked, and just having robust metrics so that you can do this kind of really quick diagnosis is very useful.
I think like data engineering is really like one of the things that I see. So when I joined Atlassian, I was just like, Atlassian has this amazing culture of like hackathons and like innovation. And so I actually found out that there were more than 60% of all hackathons ever that were machine learning oriented. And there was no machine learning engineering team before I joined, right? I mean, so really it tells you that people, there are a lot of people who know how to build a model. There are very few people who know how to operationalize a model, how to deploy a model, right? I mean, so basically like for me, like I made it my mission when I joined Atlassian to actually be able to provide solutions to deploy models at scale for even people who don't necessarily have the background to do that. And so it's really a task where you need some data science to actually like leverage the knowledge or the model that is being built, but you also need to build a pipeline or system that is easy to use for someone who's not a specialist, right? And so I think by doing that, we're really going to explode like the ability, because like within Atlassian, it's a huge problem. Like if I had this available today, we would have smarts in all the products like tomorrow, because there's such a huge pool of talented people, and models are just sitting there that cannot be deployed because we don't have the right infrastructure.
You know, it would be great if GitHub had something for model management.
Yes, you look great. Thank you.